power of A greater than B, that of C. In the column 1, the bulbs are arranged in different configuration. Is asking about the intensities. Is asking to compare the intensities of the bulb. So look at the first case, they are series. Second case, AB parallel, that effective is in series. So now look at the PA, PB, PC. So from this information, what we can gather now? The first thing is like all are having same voltage rating. So let's go for PA equal to V square by RA. The power rating of bulb is how much? PB is equal to V square by RB. PC is equal to V square by RC. PA greater than PB, that one. So what we can write, RA less than RB less than RC. So these are about the resistances. Okay, let's come the first option P. The option P, all the bulbs, they are, see, not by seeing, it's similar to just like a resistors. Huh? So in place of bulb, you bring the resistors and compare the things, finish over, no need to that one. So there's no any big concept related to the resistance of this RA, RB, RC. Now look at now how the bulbs, they are in series. So what about the current? The same current will flow through, no? And the voltage is V. Look at this. The same current will flow through all three bulbs. Then one which is having more resistance, more power dissipated, no? The power dissipated in the bulb C will be more because same current, the resistance is more. So which will have more intensity now? C will have maximum brightness. If I write down the powers, this will be PC greater than PB greater than PA. So therefore, the brightness of bulb C, this will be maximum brightness. Or if you compare the brightness, no, brightness will use symbols like this. BC greater than BB greater than BA. So for option P, what you can pick up? You can pick up B, no? Similarly, we'll analyze now. Now A and B, they're parallel. So I'm coming for option Q. So somehow what happened, just bring, instead of bulb, you can draw a resistor also, if you're getting confusion.
Sir, in first one, we can keep A also, no? No, sir.
A is having minimum intensity. No, I didn't check the column 2. A is glowing with maximum brightness. Yeah. AB will make it options. AB. Now similarly come for the voltage rating. This is the V. No need, I think we can check it here only. Look at the resistance RAB, RC. RA less than RB and it is less than RC. Means in other sense, RC greater than that one. The effective resistance of this, compare A and B, the effective resistance of this will become parallel. So what all the current will branch here, no? So the current, what it flows here, it will branch out. Call I1, this I2, and this will be I. Definitely I will be greater than I1 and I2, and the resistance of C is greater. Then what about I1 and I2 in between them? So I'll need not to draw a diagram, need not to, let's focus directly on the question and get that one. So what about I1? I1 should be equal to main branch current into resistance RB by RA plus RB. What about I2? I2 should be I into RA by RA plus RB. Okay, ratio of I1 by I2. You compare the ratio of I1 by I2, RB less than RA. No, RB greater than RA. So therefore I1 will be if I1 greater than I2. Can we compare anything about the power dissipation? So this will be little bit headache, no, troublesome because I1, I2, that one. So let's compare the voltage. Both will have same drop, no, that parallel. The one which will have less resistance, more power. Will I agree? Power, we can also use the formula V square by R. V naught you call it. So what is the drop across AB now? Let it be V naught. Both will have same potential drop. The one which will have less resistance, more power. So RA less than RB. So for option Q, what are the things we can conclude here? PA greater than PB. That much I'm very sure. Then what about C compared to C? So I should be greater than I1. The value of I should be greater than I1. So PC should be greater than PA. C is glowing with maximum brightness. B is glowing with minimum brightness. Okay, I agree this one. So for Q, so what are the options? B. Is it check it? So try to analyze using various methods. That one. So here, so still I'm telling you this one. The power dissipated, either you can, if you have information of voltage, V square by R, or if you have information of current, I square R. So pick up either of one. So here the with I1 with the currents I'm unable to conclude here. So I took help of voltages here.
Sir, can you once again tell why PC is greater than PS?
Look at the current I should be greater than I1. I should be greater than I2. At least look at the KCL. I1 plus I2 is equal to I, no? Am I right? And RC is greater than RB or greater than RA. So I square RC. Fine.
Yes, sir.
So now I'm able to conclude here. So come for similarly now option R you commit. All they are parallel, no? The same potential drop. The one which will have least resistance will have maximum brightness. So A will have maximum intensity. A is glowing with maximum intensity. So option D I can pick up. Then the one which is having more resistance will have less intensity. No, C is glowing. Okay, only option D I'll pick up. Got it now? Come for option S. Look at this wire. This wire is very important. So what about the bulb A? Will it glow? No, it will not glow. No. No current will no current will pass through it. I'll draw the diagram. Huh? I'll draw the diagram for the last situation. So this will be our bulb will come here. There's a bulb B, C, and this is A. So how the current? So let the current be I. This current I will flow here. So it cannot branch here because the short circuit path is available. So the current I will follow. So here what happen? It is having the two bulbs, so it will branch out. Call IB and say IC, and again it will combine this I. So here this what happens here. The current I, so it follows here a short circuit path or low resistance path. So no current will flow through the bulb A. Got it, all of you? Just look at the diagram. And this current I now it will branch out IB and IC. We have some information about the resistances, no? So this is option S.
Sir, will it not divide in the junction between A and B, sir?
Why again?
Because A is one resistor and B is one resistor.
Not happen. No current will flow, no? Short circuit path. It cannot again branch here, not possible. You mean to say current will come like this, again will join? No, that cannot happen. So this is shorted, no, altogether. The bulb is fused, or we'll say better shorted. So no current will pass through it. The drop across will be zero. You just do one thing, take help of Ohm's law, V equal to IR. What is the drop here? Zero. V equal to 0. Then I equal to V by R. V 0, then what should happen? The current should be 0, no? I equal to V by R. As of course, resistance is non-zero, but potential is 0, no? So no current will flow.
Yes, sir.
Got it? Okay, now we have resistance. Now RC greater than RB. That much if information is there. Or if you are smart enough, you can analyze from the diagram. No need of mathematics. So what all that potential drop V is there? I think how much drop will be here? Shall I put directly V? Because the drop here is 0. The equivalent circuit of this will be, this bulb will be shorted. As good as you remove it or keep it, doesn't matter here. Then what all the applied voltage V, what will happen? What will happen to that voltage? It will be shared by these two. The B and C will become parallel. Then we know RC greater than RB. The one which is having less resistance will have more brightness. So therefore, PB will be greater than PC and PA 0. A is having the minimum intensity, option A. B is glowing with, C is glowing with maximum brightness. No, B is glowing with, okay, that one. Only option A I'll pick up. These are the types of problems what you can expect. Some simple series parallel. Once again, just in place of bulb, replace with the resistance of a bulb, then you